Okay, this is the video for the second worksheet or the last worksheet of next week since we only have 4 days. So, combinations and permutations. Combinations, order doesn't matter. Permutations, order does. So let's get started with, there's 4 black buttons and 4 brown buttons. If 4 brown buttons are picked at random, what is the probability? If 4 buttons are picked at random, what is the probability all of them will be black? Well, you're going to pick 4. You want them all to be black, but you don't care which black button and the order they take. They're all black buttons, but there's 8 total buttons and you're picking 4. So the denominator is always the total. And that would turn out to be 1 over 70 once you do the calculations on your combinations 8C4. Now those first page, the first 4 I hope are fairly self-explanatory and you're starting to get those going. But let's go over to the back page, number 5. Number 5 takes it to a new level. We're starting out with 50% chance of the next 4 problems here, but I'm going to do them as if they might be 25% chance or 30% chance or anything like that. So, we have a basketball player has a 50% chance of making a free throw. What is the probability that the player makes exactly 2 out of 8? So we start with, there's 8 foul shots. He has to make 2, and we don't care which 2. It could be the first 2, the last 2, middle 2, any of those. He has a 1/2 chance of making it, and he needs to do that twice. He also has a 1/2 chance of missing it, and he has to do that 6 times. So 2 and 6 always equal the 8 foul shots or the 8 probabilities that we're doing. When you do the math there, 7 out of 64, and that turns into 10.938%. Trying to do this fairly quick because it takes a long time to upload, and I'm sure it takes a long time for you to get to watch them. I'll go ahead and do 6 here. A fair coin is tossed 10 times. What is the probability of landing tails up exactly 3 times? So, 10 tosses, 3 tails. Tails is 1/2. We need to do that 3 times. That means heads would be 7 times. They're also 1/2. So, this is called the binomial probability distribution, but that's just the math term of it. This turns out to be 15 over 128, and that's equal to 11.719%. So that's how we do 6. So when we get to 9 through 12, our deal here is that in the case of 9, there's 2 different ways of winning, or 2 different things that we have to consider. So we got the one day 10 babies are born at a hospital. There's an equal chance of boy or girl. What is the probability at least 9 of the 10 are baby girls? So we win with 9. We got to figure 9. I don't know if that's a win or not. And 10 counts in this probability. So we set it up just like we did. 10C9, which is 1/2. 9, 1/2, 1. 9 girls, 1 boy. Plus, what happens if 10 out of 10 are girls? And to finish the formula, that would be 10 girls and 0 boys, and to the 0 power is just 1. And when we're done with that and you do your calculations and hope it's right, I'm not going to take time to punch it in the calculator. I already did that. Or you can write it as 1.07%. So let me know how things are going. Just really finished grading last week's homework and it didn't do so well, so I'm kind of cutting back a little bit on putting so many things at you and trying to keep it more focused. All right, thank you.